Hi, and welcome to another House of Science home science video. Another taster activity out of one of our kits. This one is from our NanoChem kit, and like the name suggests, it's a chemistry kit, but we're looking at the nanoscale, or very, very, very tiny things. And I need to acknowledge the McDermott Institute of Advanced Materials and Nanotechnology. They have helped us develop this kit and also sponsor it in our branches. So they are hugely supportive. So thank you to the McDermott Institute. So for this activity, we're going to need the following. We're going to need a candle. We're going to need a glass of water. You want the water fairly well right to the top. We're going to need a pair of tweezers, or if you've got tongs, that would be good too, but I'm going to use tweezers. And we're going to need a silver coin. So here's a 20-cent piece. Right, so first of all, what we're going to do is light our candle. And any candle will do. The key thing is that you want a nice tall flame. Now, children, you'll need to make sure you've got an adult to help you with this and make sure you do it all safely. So I'm going to use the tweezers, and I'm now going to hold this shiny silver coin in the flame, and you'll see a little bit of smoke come off the top of the flame. I don't know if you can see that, but the flame is giving off some soot when I hold this in there, and already you can see some black covering my coin. That's what we want. We want to cover the coin in soot. So this activity is looking at hydrophobicity. Now, something is hydrophobic when it has a phobia or is afraid of water. So we're going to cover this coin with black soot on both sides, and then we're going to see what happens when we put this soot covered coin in a glass of water. Now, the McDermott Institute look at all kinds of nanoparticles and the way that they behave and the way that they might help us in innovative and useful ways. And hydrophobicity is a very common property that is studied by scientists at the McDermott Institute. Look at that beautiful dull black covering. So we're going to wait for that to cool down a little bit. Okay, we've got a good thick covering of soot on our coin, on our 20-cent piece, and now we're going to drop it in, or dip it in our water, and you watch what happens. Now can you see the surface of the coin? So we have a dull black covering in soot, and when we put it in the water, what do you notice? What's going on? So what's going on here? First of all, let's explore why the soot looks so dark and so black and so dull. If you look at soot on a microscopic scale, so with a microscope, you'll see it is really rough because the soot is made up of lots of different sized carbon nanoparticles. These carbon particles themselves are quite dark already, but the roughness makes it look really dull. So when we drop this coin that's covered with soot in the water, the soot is hydrophobic, which means it repels water, so we end up with a layer of air trapped between the water and the coin. And the surface of the water will reflect light because of an effect called total internal reflection. So that's why your coin looks really shiny when it's underwater, because it's actually got a layer of air trapped on the coin. Now, hydrophobicity is also something we see in nature. Many plants have a waxy layer on their leaves to prevent the water from getting into the pores in the leaves. And some also have little furry hairs on them. And believe it or not, that also provides a layer that protects the plant from getting too wet. Have a look at this. So here are some alströmerias in my garden. Let's see what happens when we wet the leaves. I'm pretending it's raining with my little spritzer bottle. And have a look at these leaves and how the water droplets are just sitting on the leaf. They're forming quite separate little droplets. That's because the leaf surface has a hydrophobic coating. How cool is that? So have a lot of fun and explore hydrophobic surfaces yourself at home. See you later.